it's a very significant project with lots of fabrication. And so we've been doing this collaboration now. I'm looking out at John and Ken, probably close to 10 years maybe. We've been doing this a long time, so it's a lot of fun. Every spring, we always have Madison College come down and talk and present with us. So we're very lucky to have them here today. UW students take notes. Again, I just want to remind students, the UW students, to put your essay and instructor evaluations in there. With that, I'm going to turn it over to the Madison College students. Thanks a lot for being here, guys.
Thank
Can
you.
I give you the mic? And I'll dim the lights.
Thank you, John.
Okay.
I'm up.
Hello everyone, we are Intro to Engineering students from Madison College Spring 2013, and this is our biodiesel blending system project. This semester, our client was Paul Morschauser, senior diesel instructor from Madison College also. And Paul is currently operating 50 gallons pilot reactor and using fuel in the spring and fall semester at our school. And Paul approached us because he would like to be able to recover methanol from the process to lower his cost of operation. As well, he would like me to able to blend biodiesel with petrodiesel and additives for year-round use in summer and winter. Darcy, our next speaker, will explain to you a little about chemistry behind biodiesel production. Darcy?
Thank you, Anna. To start, we did some research about the process of making biodiesel. The reaction is called transesterification, and oil is present as the limiting reagent. Also, methanol is present in excess, so there's some left over after the reaction. So the methanol combines with the fatty acids to make methyl esters, or biodiesel, and the other product is glycerin, which is where most of the leftover methanol is left. Okay. You can follow the path of the methanol here in red through the reaction. So our client typically blends a 50-gallon batch at a time, and that requires 30 kilograms of methanol. Over half of it's used in the reaction, and a small amount's lost in the biodiesel that's unrecoverable. The 10 kilograms, however, that is in the glycerin, that's what our client is interested in recovering. So we'll begin crunching some numbers. There's our resident number cruncher, Tony, right there. The purpose of the energy balance is just to calculate how much energy would be required for methanol recovery. So first we've got to add heat to it to increase the heat up to boiling point, overcome the forces, vaporize the methanol. We also then need to absorb all that heat, cool it down, and we calculated that by running through water-cooled coils. So with the total energy figures, we calculated the cost of the process. The value of the recoverable methanol minus the cost of each cycle yields $5.99 savings per batch. So that gives an 11-year simple payback period. Next, we analyzed building just the blending system. Biodiesel gets thick and sludgy in the winter and the cold in Wisconsin, so it can't be used unless it's blended in these temperatures. The diesel tech department currently blends at a B2, so that's 2% biodiesel and 98% petrol. The cost to fill up a 100-gallon tank is $410. So they'd like to increase to B20, which would be 20% biodiesel. And if we can build a system that would mechanically blend the biodiesel, the petrodiesel, and the additives, then we can save about $50 a fill. At the current rate of production, that yields a 7-month payback period. So based on these numbers, we concluded methanol recovery is not effective. We switched over and concentrated then only on the blending system. So I'd like to bring up Brian, who'll talk about the design and fabrication process.
As Darcy stated here, we need to blend biodiesel with petrol and an additive. So First Gem Pumps out of Milton donated us this pump/blending unit. And what this system does is actually emulsifies your B20, or not your B20, but your petrol and your bio with your additives, so it does not separate, and that's the key. So with this pump slash blender, we designed our blending unit around this. So our first initial ideas were a continuous flow unit, which will have multiple tanks, which are bulk tanks, and then you basically add them together, blend it, and put in one bulk tank to hold it. With those ideas, we talked to Paul, and Paul gave us some constraints, and the biggest constraint was, you can see right here, 3 feet by 4 feet by 6 feet. So continuous flow would not work for us because it'd be too big of a spill containment unit as well as a platform. Also, if you look here, we had a $1,000 budget, and he's only mixing 50 gallons. So we went back to the drawing board and came up with another design, which you can see here. Spill containment unit made out of 1/4-inch plates or mild steel, which actually holds 90 gallons. We have a 60-gallon bulk tank right there, so anything catastrophic happens, it'll contain everything. We made it palletized, as you can see, so you can pick it up with a forklift. And some of the other slides, there's on the side over here of our drawing, we mounted trailer jacks, so you can raise it up and move it by hand if you had to. So here's our fabrication process. You can see we're starting to lay some stuff out, starting to weld everything together. Down here is our finished spill containment unit, which will hold the bulk tank for recirculating. And right here, we're going to basically send that out to get powder coated. Now I'm going to bring up Brandon. He's going to talk about your plumbing and electrical portion of it.
Thank you, Brian. So our major task with electrical was that we are operating this blending pump on 240 volt AC 3-phase power. But we got to plug this thing into 120 volt single-phase power for any line, for any standard wall jack. So what we have here is a VFD, a variable frequency drive, which converts that power from single-phase to 3-phase. This is our electrical schematic. As you can see, we use a 20 amp circuit breaker as circuit protection in case there's any shorts. We have a GFCI outlet here as our junction box. This allows us to plug in a transfer pump and a flow meter. And of course, we have the variable frequency drive, which converts that single phase to 3-phase. For the plumbing, we use a recirculating batch system, which takes the mixture of biodiesel and petrol, pulls it through a series of ball valves through the blender and back up through into the tank. And we use a flow meter to monitor how fast that fuel is flowing through it, so we can get an idea of how long it will take to adequately mix the fuel. We also use a bidirectional fuel transfer pump to fill and empty the tank, so you don't have to do it by hand. This is a picture of the actual system that you'll see outside. Some things to note: we have a sight glass here, so we can see the level in the tank. We have a exhaust vent, so that way there's no back pressure when we're running the pump. The transfer pump is here to load and fill and unload, and the blending pump is here. And what you'll see also is that we have PVC right now. That's temporary for testing, and we're actually getting a donation from Apache Stainless to get all stainless plumbing installed before we use it for production. As for our timeline, we had a major delay in time materials acquisition. It took a lot of time to coordinate with our donors to get all the supplies we needed, but it was well worth it. We worked a lot of weekends and nights to catch up to present today with a functioning unit. And Darcy will go over the budget with you guys.
Okay, great, thank you. The client gave us a $1,000 budget, of which we spent $835. However, if you see over on the right side there, the generous donations from our donors made it possible for us to give our client a finished product that's worth $17,500. And again, here is just a slide just to show you all of our donors. Apache Stainless donated the tank, the actual tank, and like Brandon just said, we'll finish up our project with stainless plumbing. Baldor donated the variable frequency drive, so we were able to convert the electric. Cook's Countryside Trucking helped us in transporting the materials, so both here today and back and forth to school, to the shops with the metal. We use their trucks often. Silverline Digital came in at the last minute with a nice cash donation to keep us under budget. EK Machine did the powder coating, so you see in some of the preliminary slides up there, our product was not quite as finished looking as it is now. Fristum donated the blender / pump, and that around $10,000 that really set the machine in motion. McFarland Manufacturing then donated the steel for the spill containment unit for the platform. And so, like we said before, the unit is outside, our finished product. If you guys have any questions, there's a break right now after us, so if you want to come outside and look at it, any questions, we can help you with that. And thank you. Yes.
Right away, this is fantastic. If you go back to the beginning, I'm just trying to understand what the waste product is, what you're mixing to get the
Oh, sure, the
ethanol
waste-
out again.
Sure, no problem. What they use is vegetable fryer oil, so.
Okay, this is from the kitchen or something?
Exactly, I think,
Okay.
yeah, they've had several different companies that they're just different places, they've just asked for it. That ask
Okay.
for, can we have your old vegetable fryer oil? And it gets purified, they take out the chunks of French fry and whatever else was fried in it. And then we just run it into the reactor that's happening at school, yep.
And you add methanol to it and you get biodiesel out. Is that it?
So, right, we first take the methanol that's activated, you can see the catalyst there, the potassium hydroxide.
Okay.
That activates the methanol, it makes it hungry, basically, for those fatty acids. Then the methanol can come in, they pop the fatty acids off one at a time. When that combines, that makes the methyl ester.
And the gentleman ultimately wants to use the biodiesel to run...
To run vehicles, he's the diesel tech
Got
senior, so he wants to run vehicles with it. Right now, we're using a very, and he also teaches a biodiesel class.
Okay.
And the thing about this reactor was 7 years ago, is that right, Ken? 7 years ago, that reactor was the Madison College's project presented here.
Oh, Madison College was the client.
Madison College was the client.
You won a 16
Sorry,
engineer.
UW
built the
president.
reactor.
So that's where the
Keep going
that's
back to
where
the
the reactor
previous
came
slide.
from.
Go back
Wow,
to
Jesus.
right there's the reactor that Paul uses right
So,
now.
was that with Mark Anderson or something
That was
like
built
that?
by Mark Anderson.
Oh, really? Okay, that's the connection. Cool.
So what happens in that center silver pot, that's where they take the methanol, the potassium hydroxide, that's where that gets activated. And then the fryer oil is pumped into that big tank on the left.
Okay.
So the fryer oil, then once the methanol is activated, it goes into the fryer oil, and then through that transesterification reaction, everything's recombined. Because they have different densities, the glycerol and the biodiesel, they settle out, so then they drain off the glycerin that's left over, and
Do you see something like this as potentially scaling up? Because I mean, the simple payback of 11 years is very, very good, I think. Again,
right, and
industry
there,
may want shorter, but would this scale up to, could you build a plant?
And in the industry, they already are. What they're doing is
Yeah.
a continuous system. It's not a small batch system like we're doing here.
They gotta-
So what they use, when they're using the heat to heat it, they use that heat also to heat your methanol to recover, or
Okay.
your glycerol to recover your methanol.
The reaction's exothermic, so it just gives you the heat that you need on board.
Okay.
So they do that in a continuous process.
Like all three actually use the glycerin as fuel to heat up the old glycerin that's like methanol too.
Very cool. Yeah, I mean, right now would be a great time if everybody, we got, our next talk is until 6:40, so if people want to go outside and take a look.
we'd love you to want to take a look at it. We're working right on it.
Are they gonna run the, yeah.